we wish to analyze an indeterminate beam, using the force method. The beam, fixed at both ends, is subjected to an inclined force. There are 6 unknown support reactions. This means there are 3 redundant reaction forces. Let's make the reactions at B redundant. That gives us a cantilever beam, which is going to deform like this. We are going to label the 3 displacements, delta 1, delta 2, and delta 3. We need to calculate these displacements. Let's start with delta 1, the axial deformation of the member. This deformation is due to the x component of the applied load. We can write axial stress equals E times axial strain, or since P equals 5 and L equals 3, then we get 15 over EA for delta 1. Delta 2 is the vertical displacement at B due to the vertical component of the applied load. To calculate delta 2, we need to write the moment equation for the beam using the applied load, and the moment equation due to a unit vertical load placed at B. Then, we calculate delta 2 by integrating the product of the 2 moment equations. That gives us 195 over EI for delta 2. Delta 3 is the rotation at B due to the vertical component of the applied load. So, we need to write the moment equation for the beam using the applied load. And the moment equation due to a unit moment placed at B. That gives us 39 over EI for delta 3. Since we have 3 redundant forces, we need to replace each one with a unit load. Then, we calculate the 3 displacements that result. Let's start by replacing Bx with unit load. We are going to refer to the 3 displacements as delta 1 1, delta 2 1, and delta 3 1. Delta 1 1 can be determined using the stress-strain relationship, like this. So, delta 1 1 equals 6 over EA. Since an axial force does not cause vertical deflection or rotation in beams, then delta 2 1 and delta 3 1 equal 0. Now, let's place a unit load in the y direction at B. Then, calculate the 3 displacements that result. Axial displacement, delta 1 2, due to the vertical load, is 0. To determine the other 2 displacements, we start by writing the moment equation for the beam, due to the unit vertical load, and due to a unit moment placed at B. Then, delta 2 2 can be expressed as the integral of m1 squared. And delta 3 2 equals the integral of m1 times m2. Finally, we place a unit moment in the direction of MB. Then, we calculate the resulting displacements. Again, axial displacement, delta 1 3, equals 0. Given the 2 moment equations that we determined in the previous step, we can write Knowing all the displacements, we are now ready to write the necessary equations for determining the redundant forces. Here are the equations. Solving them for the unknown forces, we get Now we have a statically determinate system. We can calculate the remaining support reactions with ease. Here are the results of the analysis.